Yo, what's good, guys? So today we're going to be going over this integral tan to the fourth x dx. It's an indefinite integral, and it's from the MIT Integration Bee problem sets. It's from the year 2015, and it was the 18th question out of the total of 20, which get harder as they go on. So this is definitely up there in terms of difficulty, especially since these are intended for undergrads at MIT. So who are like especially adept at integration. So to get this started, what you're going to want to first realize is that you're going to want to use this identity. So what this allows us to do is just rewrite this tan squared x. Well, let me first rewrite this integral. So you should realize that these are the same things. Like if I had x squared times x squared, this is the same as x to the fourth. So that's essentially what we just did, is we just divided the integrals into something that we could multiply. If we really wanted to, we could do tan cubed x times tan x, but that doesn't help us at all because there's no identity that allows us to really do that, or to alternate that. I'm sure if you did that, you might be able to solve it, but it's just not nearly as easy as this, since the secant squared x, the integral of that is just tan x. And then 1, the integral of that is just x. So if we rewrite it in terms of this, we know both integrals pretty easily. So the problem with rewriting rewriting both tan squared x and tan squared x, rewriting both of these in terms of this, is that we're gonna multiply and get secant to the fourth x and do all that sort of stuff, and in the end we're just gonna have an even more complex problem than this, because we're gonna have like secant to the fourth x plus like secant to the third x plus like secant squared x and etc. plus like 2 secant x or something like that. So it's just going to be even more complex. So rewriting it in terms of 1 and then splitting your integral is going to be the way that you want to go. So what that'll look like is this. So we're going to want to rewrite one of these tan squared x in terms of secant squared x. So, and then you're going to want to keep the tan squared x, because obviously since we just rewrote one of them, we're still going to have this left over. So next you're just going to want to distribute. Let me rewrite this going across. That's a summa sign. Okay. So one thing that you might notice is that since there's minuses here, splitting the integral is a possibility. So that's exactly what we're gonna do. So okay, and this whole part of the integral right here, we're not even gonna worry about until later. We're just gonna keep working on this. So I'm just gonna start rewriting this part of the integral in a different color. So what you're gonna want to do is realize, like, oh, if I set tan squared, if I just mine it, just don't even worry about the powers right now. Um, Obviously we can't do integration by parts because they're both trig. Um, Obviously, this isn't solvable by any, like just power rule or something like that. And so yeah, so really the only option that we have left that makes any sense is u sub. So not even worrying about to find what your u is, don't even worry about these like exponents right here. They don't matter. What you're going to want to do is just see, okay, well I have u sub, so I need a function and its derivative. So not worrying about the exponents, you should be able to say, okay, well secant x does not, the derivative of that, um I don't even like it. It's not even gonna work at all. The derivative secant x is not related to tan x, and not really in any sort of relation. So the derivative of tan x though is just secant squared x. So it's basically the same. Especially since looking at this problem, you should be able to also see that we have a secant squared x. So tan x is going to be the one that you want to use as your u. And then now du is just going to be, actually you're going to want to do just tan x. So our derivative of, the derivative of this um, is just secant squared x, obviously, dx. So what you're going to want to do is just straight up just do u sub. So u squared du. Okay. Well, this we know we can just do power rule. This is just equal to 1/3 u cubed, then plus c, but we'll write that at the end. So you're just gonna want to plug back in u, so you're gonna get tan cubed x over 3. And then so this is this problem. This is this integral. We're all done with this integral. So now we're gonna move on to this one. So let me just start doing this in a different color. So with this integral, we're kind of gonna want to just do the same thing, except up here we had 2 tan squared x. This time we only have 1. So we're just going to rewrite it in terms of this up here one time. Alright. Dx. Okay. So once again, because they're minus, we can just split this integral. Okay. There should be parentheses here to signify that this negative goes to all of them. Okay, well, integral of secant squared x is just tan x, and this is just x. So this is our this is this is this. There should be a dx on both of these. Same thing. No, not same thing up here. So this is negative tan x plus 1, and then you're gonna want to add that to this. So your full answer is tan cubed x over 3 minus tan x plus 1 plus c. You should see that like all we did was solve the we just rewrote the integrals in terms of this up here, and then we split them and then solved each individual part. So yeah, let me just rerun through this. We split this integral, or we rewrote it first. We rewrote this, and then we distributed here, and then we split the integral to get this. We worked out this integral using u sub to get this, and then we minused, since we had to minus these two, because up here they were minused in the original problem, and when we split it they stayed minused. Then we solved this one with the minus out in front. We split this integral. We split this integral again. We rewrote this using the identity. Then we split this, kept the minus out in front, applying to both integrals, did the easy integrals, and then multiplied them through by -1 to get this. And then since they had to stay since we kept the minus, they didn't have we could just add them. So we just added them and got tan cubed x, which was our first integral, minus our second integral, and then we kept the plus c. So this is your answer. So that was just a lot of rewriting and splitting, and then just doing, after that it was just pretty basic. It was just basic u sub, and then basic identity integrals like secant squared x and 1. So I hope you guys enjoyed that, and I hope that you learned something.